Hello and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the program manager for the Recycling Market Center and will serve as your moderator today. Today we're going to discuss the triple bottom line for recycling, and our presenter is Lisa Skumatz, who I will introduce in a moment. We're going to have a Q&A session at the end of the presentation, so if you have a question or comment, you can use the Q feature located on your control panel on your screen. And please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition Pennsylvania Recycling Center websites. And also note that the Pennsylvania Recycling Market Center affiliates, funders, and the National Recycling Coalition assume no liability result in use of any information provided during this webinar. This webinar is only provided as an informational tool, and discrimination is intended, and no endorsement by these organizations is implied. Dr. Skumatz is an economist and principal of Skumatz Economic Research Associates, also known as SARA. She has a nationwide reputation in integrated planning, program evaluation, revenue options, economic and policy analysis, outreach, engagement, and scenario analysis and forecast work conducted for solid waste clients at the local, county, state, and national level. She has worked for over 1,300 communities across the United States and international projects as well. Her interests include both all quantitative and policy issues, focuses on facilities and programs work in the real world. Lisa has the unique distinction of winning National Lifetime Achievement Awards from both SWANA and NRC. Dr. Skumatz is currently chair of the National Recycling Coalition's Board of Directors and is a member of numerous national, state, and local civic, environmental, professional, economic, and waste management and recycling organizations, having served on many of their boards of directors. Okay, so I'm going to turn the program over to you, Lisa.
Thank you. I'm really pleased to be here. Thanks very much to the NRC and Pennsylvania Markets Council for inviting me to speak on this topic, a topic I think is really interesting. And could you chat and let Wayne know if the sound is coming through okay, or if it's not? Thank you. I'm going to be talking about conducting all aspects of a triple bottom line, or TBL, for recycling. And I'm going to also talk about the social side of it, which is commonly ignored or hand-waved at. Okay. Fine. It doesn't want to proceed. Let me just. There we go. The topics I'll be talking about are, first, I'll give a little bit of background on in the literature. Pardon me for a second. And then how you can develop a list for what effects might be relevant for the triple bottom line elements, how you can value the economic and the environmental, some options for valuing the social side, and then a couple of examples from some work that we've done and some conclusions. So I'm an economist, so for me, when we look at whether or not to invest in a program or make a policy change or something, we do benefit cost analysis. Look at all the benefits, look at all the costs. And theoretically, it should be all of the benefits over all of the costs. But what we find is that when things are hard to measure, or HTM, hard to measure, they often get left out of an equation, and that leads to a biased result. You don't include all the benefits, or you don't include all the costs, so the true benefit cost analysis is not what you're deciding on. That leads to a bias, and you just need to recognize it at the very least and hopefully improve it as a better step. The triple bottom line tries to sort of remind people in a way that there are a whole range of benefits and costs, not purely economic, but rather economic, environmental, or we might call them externalities and other things in the economics world, and also social and people and those sorts of effects as well. All of those are to be included in a true economic benefit cost analysis. Triple bottom line makes that explicit. Triple bottom line gives us a much fuller benefit and cost, but remember that it is meant to include all the positives and all the negatives. So you're not meant to make a case here. You're meant to provide an unbiased or less biased explicit way of looking at the benefits and costs and make an informed decision. It's really important for sustainable minded businesses and communities, and we find that We find TBL reports in the literature quite a bit for both of those. Some folks require, some cities require a TBL analysis, and most do not. And there is a little bit of a difference in perspective. Certainly, I think cities have a special mandate or a special responsibility to look at the social side that businesses, yes, they should, but cities, it's kind of their business to be looking at the social side of things as well. Their residents, their businesses, but the well-being of their community is an important part of the mandate for elected officials. And I'm a former elected official. I certainly felt that pressure, and I'm sure most of them do as well. When we look at a triple bottom line or a benefit cost, the basic benefit cost is sort of the direct benefits and costs, those dollars and cents you're spending for program A or whatever. A little bit better is to include things like net tip fees and other things like that, a little bit better. More is including the economic, the environmental, and then at least some of the basic social. Maybe it's case studies, maybe it's stories, maybe it's things like that. But best is to use something that truly values the social side of things. And we're going to give you some idea of how you can do that in this presentation. And it's not, and when I say quantified, I mean monetized. Yes, I'm an economist. I get that that's a bias, but when folks are considering investing, very often, let's say I work in the energy side as well. And if I'm trying to look at social things and the engineers are presenting things with, dollars and cents down to 15 decimal points and whatever, it's a hard case to go, oh, but this is really better for the citizens because something very soft. If I do that and the engineers have all their numbers in a great spreadsheet or whatever, my argument is likely not going to win, or at least it's not going to have the traction it ought to. So putting it into dollars and cents to the extent possible is really valuable. Putting it all together into $1 and cents thing, so sum it up, subtotal, and a final that gives the totals is really important if you want it to be taken seriously in a true benefit cost analysis. So I think it's really important. Otherwise, the investments will really not be considered on the same level. What we find in the literature is that doing a TBL or doing the first parts of a TBL are not hard. The economic and the environmental, and I'll give you how to do those. It's really quite common. I see monetized for those things quite often, but I rarely see monetized social side benefits, even in advanced communities. I see a qualitative, I see lists, I see checklists, I see positive lists and negative lists. I see things like that, but I do not see really monetized numbers, even for advanced cities. I see it a couple of times for several of the benefits, for some water investments and wastewater investments, and a few others. I saw some for a tree planting project, things like that, but really not in the recycling side, and not in a really quantified, monetized way. Social should be an important consideration for communities. And if you don't have a value in there, missing means zero in a benefit cost analysis, and you are introducing bias right away. I'm going to make one point a couple of times here because I think it's really important. A deep dive or quantifying everything is not always necessary if you're using it to drive a decision. If you're using it to understand the full impacts of a policy, then you would like to go down and dive in as much as you can on lots of the different effects. But if you're looking at driving a decision or not, then you may not need a deep dive. You may need to quantify just as many social impacts as are needed to get the benefit cost ratio to greater than 1, or the positives greater than the negatives. That may be all that's needed. That's some kind of a threshold analysis to say, yeah, and here it is with the numbers, but there's this whole list of other things out here that could be quantified. They are all net positive, and so they will only improve the situation for the decision-making information I'm giving you. But in any case, remember that it's not, when you're taking on a social, one, it's not great to just do one, but two, if the one gets you over the finish line, then maybe you can relax a little bit on the quantification of some of the other benefits that may be even harder to measure. But be really clear that the things you're leaving out are on balance positive, otherwise you're undermining that case, and you will have to go into looking at least some of the negative ones to be fair. What I see in the literature are things like lists. So, here are the effects on the economic side, the environmental side, the social side, and there are effects. I don't see dollars in this. Here's another list, and it includes things that are sort of positive or strengths and negatives or weaknesses. And I do see lists like that. These kind of lists can be starting points for what things you would analyze or quantify. We have pulled together from various literature the kinds of typical elements that you might include in a benefit cost analysis for a recycling type project. And they include direct, indirect, induced economic effect, as well as environmental changes that are happening, and then also the social impacts. And so we've put together from the literature a wide range of types, social and indirect type effects, 2 columns worth. And where you get sources for this, well, we've pulled together a lot from the literature, from some work that we've done, from interviews with subject matter experts or SMEs. You might like to conduct some local focus groups with citizens who might be affected by the program you're doing, to get an idea of what things they might consider positive or negative potential changes from your new program, and go about estimate and look at those as things to be added to the list. And these include things like system resilience and risk, which can be kind of tricky to analyze, health and safety effects, which can be analyzed, quality of life, some things can be analyzed in it, home values and so on. Land use adjacency, commute time, things like that can be analyzed, but they take different methods sort of for each one. Here's the easy list of things that we do pretty commonly when we do triple bottom line work for clients on recycling projects. We look at the direct benefits and costs, sort of the model tons, the city costs. The ones that should be done that include things like the net tip fees and the generator costs as well. Cities are usually funding these projects. We're looking at what the city is going to have in terms of budget effects, but we need to look at but if you're really going to look at the enhanced benefit cost, even the direct benefit cost, you'll want to look at the cost to the generators, that is the households and the businesses as well. And very often that can be a not positive effect. Most of the changes we're going to make, at least in the short term on the recycling side, are going to be higher cost to the generators or higher cost to the bill payers, because if it was cheapest, it would probably already be done now. That's a little skeptical, but you get the idea of what I'm saying. So those are part of the economic effects that you need to consider as well. For economic activity, those are jobs, taxes paid, output, economic jobs and multipliers for restaurants and whatnot for the workers or whatever. Here you model the programs in tons and use the input-output model to estimate, and that has some economic effects, but it also has some social effects, because if you're talking about jobs and things like that, that can be a social effect as well. Vehicle miles traveled can be affected, and that's really quite easy to estimate, both in terms of street damage, which is sort of economic, and in terms of emissions, which can have both environmental and social effects. And by social effects, for emissions, we're often talking health and safety, additional deaths from emissions of things related to fossil fuel burning from trucks and whatnot. So that's what we might look at, and for the street damage, we're talking about different. You do the routing effects, and you figure out how many car equivalents and how much faster you're going to have to repair the streets, and that's a direct cost to the community if you're adding routes or adding distance or things like that. For emissions effects, we look at the net diversion and reduction. So we model the tons. We use an emissions model to translate that into metric tons of carbon equivalent. We use a social cost of carbon value or a special model to figure out what the health and social effect damage is. If we, and we can also do a break-even analysis to figure out how much social effect is needed in order to turn the decision into positive or clearly positive or clearly negative. Social cost of carbon has multiple values, and that's why I say that, because some are relatively narrow and maybe only be accepted by certain kinds of audiences. Some are much broader, maybe if accepted by audiences with a broader perspective and more sustainable oriented and so on. And in that case, you might need the breakout even analysis to say, well, we need at least this much value. This much value already turns the decision, or we need a great deal more value. And so you'd have to be interested in looking at the health effects and so on. There are also a number of other social effects, and those social effects, I'm going to say, devolve mostly to case studies in most communities that I've seen triple bottom line. It'll be the low income neighborhood is going to have more trucks through it, and so therefore there's a negative effect or something like that. But based on some examples I'll give you later on, there are many more effects that can come about, and they can be measured, but you need to use special techniques for doing that, and we'll talk at some level about that. So what are some sources for quantification for the economic side? It's not that you don't know the math, but I did want to say a couple of economic things, which is one, you need to look at net changes, not gross changes. So you need to figure out what changes this is going to provide in, say, tons or costs above and beyond what would have occurred without your program. You can't just, and it may not always be pre-post. It may not be now versus later. It may be now, but with the new rate increase they're going to charge us at this landfill starting next week, and we're going to compare that with the new system. So you don't get to always do just pre-post. It's sometimes pre-adjusted and post, or a dynamic baseline, or things like that for those who are more sophisticated in the audience. Another thing that it's quite easy to figure out the tonnage and the direct service costs on, say, things like collection and processing. What are the new facilities going to cost? What are the tip fees, the revenues? Also, you'll get some financial benefits from closure deferrals and so on and so forth. So there are several effects that come in. Also not hard is the wear and tear on city streets. And there you'll look at the pre-post routing, number of trucks, number of truck miles, and so on. If you don't know the routes now, if you have, say, multiple haulers or something like that, you might use city miles from the census or I've got them from the web on lots of communities, and maybe add a factor for the fact that they have to go back and forth and repeat a little bit. And that's one of the things you might use. And if you've added a truck route, that's pretty clear or a new service, say you're adding organics to an existing system of trash and recycling. You're adding a whole set of trucks potentially if you have an adjusted frequency. There are some numbers in the literature that say maybe 800 to 1,300 car equivalents is a trash or recycling truck. And we've really looked at the literature in great detail and have found, while that number gets councils and public works directors all excited and worked up, when we've worked through the math on the few appendices that we've been able to find and figure it all out, it's really a pretty small effect based on the limited publications we could find. So yes, it's a big number, and yes, if you want to scare them, I guess you can use that. But if you're going to bring it to dollars, we've not been able to find numbers that are anywhere even approach $1 a household a year. But you might have better sources than we did. We didn't do that engineering work ourselves. We just looked at what was published, which might not always be what is always, really well available. But anyway, just as a tip. One of the other things that's an economic effect is sort of job effects. And job effects are a very simple calculation, is using the work from the Institute for Local Self-Reliance, not that, it's sort of a long-standing number. For 10,000 tons of solid waste landfilled, it's 1 job, and composting, it's 4 jobs, and recycling, it's 10 jobs. So you can figure out the net job change pre and post as you move from, all the tonnage landfilled to some of it landfilled and some of it to the organics program or something like that. And you get to multiply times those net job changes. So you get 3 more jobs for every 10,000 that go to composting, that sort of thing. And then you can multiply it times an average laborer or something like that to get some of the economic effects. But I will say, especially if you're talking about recycling, those 10 jobs are not local. So if your perspective is local, then that 10 jobs or that 9 net jobs is not what you'll be using. You'll have to figure out some other factor about it, and it will be kind of ad hoc, but it's better than nothing. So you might want to think about, composting tends to be local. Recycling, not so much. It's all over the country. So if your perspective is your town, that's one thing. If your perspective is your state, a little bit better. share of them. If your perspective is nationally, well, then the 10 jobs probably counts, or closer to it, depending on exports and the rest of it. A better way, and the way that we use when we have budget available, is estimating jobs and economic triple bottom line elements using an input-output model. We use one of two models, either IMPLAM or RMC2. And for that work, you get estimates of jobs, income taxes, output, induced and direct, and you can do it at a local level, a state level, or a national level. This may not have been the best place to put it, but I did want to remind people about jobs. Jobs are positive in some ways, but I can make you more jobs tomorrow by saying the new policy is we will have 3 people on every trash truck. Is that a positive? Jobs are positive and negative in some ways. They are not always cost effective. They can cost, labor being a big cost. So be careful about how you're valuing jobs. They have some positive effects, but they certainly have some negative effects as well. Jobs are not everything, but anyway. And you also need to think about which jobs are local. So you need to look at this modeling work at the various levels. Here, to do this modeling work requires multiple inputs on the tonnage changes, the collection transfer, and so on. But you buy local data to get local specific industry multipliers and specific, effects for the various industries that will be affected. You have to figure out how much is going to go to each of all these different SIC or NAICS codes, and go ahead and put in the pre-case and the post-case, look at the differences and see what kind of job creation happens. It can tell you in industries as well, and you get direct, indirect, and induced effects, sort of multiplier effects. If it leads to more people working on the construction site, well, and they may have lunches in the downtown area, that sort of stuff, and as well as the effects on your local manufacturing or other industries. So that's the kind of thing you get when you do a model, and that's really detailed information. What about the environmental side of things? On the environmental side of things, we can model. The first step is modeling sort of the net tonnage changes, and so you need the base case and then the test case after your new diversion happens. And so you have a model and you come up with what are the base case and then the after the programs case, and all this was landfilled, and now it's not all black anymore, it's different colors and so on. And then you can use that to translate into net emissions. This was just from some project that we had. But you also may want to go to the embedded energy as well, and that would have some other kinds of effects and important effects as well. I'm not going to talk so much about that one. I do worry a little bit about double counting when I do that as well. But let's talk about what are the sources for the environmental effects. Well, I've tried to look at all kinds of things, including the externalities from landfill, water, soil, etc. And I have combed the literature. So if people have better numbers, oh my gosh, I would really appreciate it if you would email me those numbers. But the only study I've been able to get that gives me $1 per ton or $1 effect is Cape Town, South Africa. And they provided an estimation that was, above and beyond the soil, the environmental effects or externalities from the landfilling itself were $18 a ton. That is not the best, and there are certainly models that take everything into account, but I'm trying to sort of to look at just the landfill portion of it. And so that's then needs work. You could run scenarios and say if it's double that, if it's half that, whatever. There are lots of ways to get around it. There are, but I haven't seen in the academic literature things that I felt really comfortable with, but just an idea of the kind of thing you'd be looking for one of the effects. There are also greenhouse gas emissions effects, and those are the ones that are particularly easy to measure because you can go to WARM model, the ICLEI model, and other models, and you can translate those tonnage changes, tonnage that's new recycling gone from landfilling or new organics gone from landfilling and so on, and get these factors in terms of metric tons of carbon dioxide equivalent or metric tons of carbon equivalents and also BTUs. And use one of those to translate to dollars, to translate to the value of the emissions effects of the tonnage change or transfer. Here's some valuations for emissions, and you can use some conservative values or less conservative values. And the more conservative values, say these ones that tend to be around $40 a ton, or sort of clean power plan, conservative, relatively narrow list of the benefits. Some of these more aggressive ones, $200 a ton, include some or all of the health effects as well. You can get more specific though. We sometimes use, to get at purely the health effects, we use some EPA models that give us information on those things if we translate to do a couple translations to get there. We also had some values that we found for SOx, NOx, et cetera, that may be useful to you as well when you're valuing some of these effects. Vehicle miles traveled also produce more emissions. So here you need to look at the old route miles, the new route miles, figure out the difference, maybe any consolidation effects to get you to the net residential and commercial vehicle miles traveled changes. Multiply those times the mileage for each kind of truck. Part of it might be routing, part of it might be hauling, part of it, some might be collection, some might be hauling, and so on. And then use these various translation factors for carbon emissions, methane, nitrous, and so on and so forth to figure out what will be the effects from the vehicle miles traveled emission changes as well, and dollarize that using those same numbers that I showed on the last slide. You might have some complicating factors because, again, multiple haulers and so on, but I think you can come up with some estimates using the city miles and so on. What about the social side? Well, for the social side, it is hard to measure. A lot of the social effects are hard to measure. And as I mentioned, they're rarely quantified in trash. We did find some numbers in water and some other places from city studies and others, and some even corporate studies often hand wave at the social side, even if they claim they're a sustainability company, or they give numbers that are units of something, but they're not units that bring us to dollars that let us put it into a benefit cost equation, that let us seriously consider it on the same level as things from engineers or things from whatever. One of the other difficulties is we'll often see it's one thing that's measured, while there are a whole host of effects that are on the social side. We'll see one thing called out and the rest are punted at. And that's a shame. And there are difficulties definitely in measuring equity and other things. But anyway, we'll talk about that. So poor is to omit the social side or hand wave or whatever, because any effects that there are essentially counted as zero in that equation, and that's not a particularly beneficial benefit cost analysis, or not really triple bottom line. It is sort of double bottom line. Slightly better is to do a list, or a list that's sorted by pros and cons, or positive and negative, or something like that. Maybe ranked as well. That might be a little bit better. Certainly better is to come up with a scoring metric. A scoring metric is, it gives you a chance to say, it's better and it's this important, or it's worse and it's this important, or something like that. That's somewhat better. To beat that up and get some secondary literature, mashing it, for a few of the benefits, but perhaps not the entire list, is better yet, and like that. Best is a tailored approach that using some advanced valuations for many of the net effects that come on the social side. So let's talk about a list. Here's a list from a community, and one of the difficulties from the list is, even if profit and planet were monetized, which they are not here, the people side, to inspire people to take positive action, to identify brand imaging, things like that, container standardization. It's difficult to know that it's either mixed units or no units. It doesn't show the relative importance of these various things, and maybe you could even put that list into sort of a 9 by a 3 by 3 list, or a 9-celled list, where you have, say, economic, environmental, and social, and then important or highest value, medium, and low value. And at least that 9-celled thing would give you an idea of which things are important, and be able to balance some of those off of each other, or most valuable, least valuable scores. That would at least get you something better, and definitely positive or negative at the very least. Here we do see some of those sort of positive and negative things, but again, it's not quantitative, which would be better. Better yet, So that next level is a scoring metric. Okay, so for scoring, you can use sort of high, medium, low, but a lot of times you're comparing A to B. So, the past situation with a new situation. And so what if it was high before and it's high now, and so on? So we tend to use better or worse, and much better, much worse, that sort of thing, because you're comparing two situations. You're not comparing one situation alone in most cases. You really do need to look at with the changes. So unless you're working from a blank slate, which is pretty uncommon. So B for better, M for much better, S for same, that sort of thing. And come up with something like that, weight it for which is most important, of your, is health and safety the most important thing, and social justice is important because it's a recent study or something like that. That'd be a thing to do. And then you could score these as like 1, 2, 3, come up with an unweighted average, and it's a 1.2, and it would have been way better if if I'd put what the sort of level is. I think it was, pardon me for not putting the scoring down. I thought I had it, but in any case, you get a score, and then, I see, much better is 3, and much worse is -3. So same is 0 over on looking at the slide on the right. So you get an unweighted average, and then a weighted average. So the unweighted average is a 1.2, which means it's somewhat better, going towards better. If you do the weighted, because you care about which things are most important, then you're going towards the better rather than the somewhat better. So, clearly better as opposed to a little bit better. So that's the other possibility. If you can do another approach, which is to weight it, but also recognize that some things that, much better, if you use 1, 2, 3 and -1, 2, 3, you are assuming that the difference in perception by people between somewhat better and better, or same and somewhat better, is exactly the same as the difference in perception or value as between better and much better. And that may, in fact, not be linear. Much better might be, out there on the scale compared to better. So that last column lets us get toward that scoring and toward that recognition that, in fact, the move from same to somewhat better is less than the move from somewhat better to better, and is considerably less important or less valuable or less impactful than the move from better to much better. So you can see those are the weights that we use on a lot of our work, based on some research we've done, primary and secondary. And so using that weighted scoring and recognizing those differences, not linear differences, would lead us to a weighted score of 1.7. So that's a scoring method that you can use, and you could go through a whole host of these impacts, and you might want to be really careful. And on your impacts, you might want to look at the scoring impact. You might want to look at differences in who's affected by some of these things. Some of them might be, business, resident, or social, utility social, or participant, people who are actually directly participating in the program, compared to those that are the sort of broader city-wide impacts. So there are differences in how you might want to analyze this based on what kind of a program you're talking about. Secondary research gives you another way to monetize some of these effects as well. You may be able to get some information from interviews with subject matter experts, or folks who have analyzed some angle of that list of things that you've got on the social side that I listed here. And another thing is to do a lit search. There is some information in the literature on a variety of different things like the land effects of construction and worker risks you can get from industry and insurance factors. You can there is some academic information on crime and some social justice scores, but it's tough to get to the real dollars from some of those kind of factors. We can do the modeled effects on jobs from input-output modeling, and also we use models to get the health and safety effects from some of these as well. But you might end up using a hybrid approach. You might end up saying, okay, these we can monetize and put those in the table, and then come up with a scoring, use the scoring metric for some of the other effects, and use and or the 9-by table I was talking about a minute ago to get you scored or unscored ones, and highlight the ones that aren't yet valued, so people get an idea of what the part you have been able to value omits and where it scores relative to other things. There are case studies are sort of the most common thing I see. Okay, it has an effect on this neighborhood because now it's got more trucks going through that neighborhood because the landfill is now in that direction instead of that direction. These people were already poor and they're already put upon, and social justice issues and the rest of it, and so on and so forth. And so you might do a case study thing there. That, and that's what I see. If I do see any kind of monetization, it tends to be of that nature, which leaves out a whole host of other things. And I want to say that the case study saying it's a big effect on them is going to be far less seriously taken than a clearly monetized business cost of something or other. We, because of a variety of work we do in the whole of resources, not just trash, we've come up with methods to measure important, hard to measure effects. And we use some specialized surveys to monetize a whole array of impacts to local stakeholders, whether that's households, businesses, haulers, operators, etc. It's an academic approach. We derived it in an ad hoc way, but then we went back and modified it when we found academic literature that supported that approach, and found a lot of benefits of doing this kind of work. It allows for monetized computations. It's something that, we have to do surveys, but the way that we do these surveys is not, is easy for people to answer. And that's really important. A lot of the resource literature implies that to value some of these things, you need a willingness to pay or a willingness to accept survey. Well, if you ask a low-income household how much it's worth to them to have less noise, fewer noisy trucks running down the street, I'm going to guess that, given that they may be worried about, the next meal or whatever, coming up with a dollar value from the blue sky, or even a bounded one where you say, is it here or there, or, is it more than this sort of thing, is really hard. We find that from doing literally hundreds of these, well, thousands of these surveys, that people and even businesses have a hard time answering questions that are asking someone to relate something to a dollar, or assign a dollar to it, or even assign a percentage to it. Those are really hard concepts for businesses, surprisingly many businesses, and maybe less surprisingly many households. Many people are not math people, and much as I love answering surveys, I feel it's my job to answer surveys, but anyway, it's only fair. But much as I like numbers, I would have a hard time assigning a number to a lot of different things. I know they use that for the value of public goods like parks and other things. It is really, really hard. Using this approach that asks labeled questions, we found really significant impacts, and we found that people can answer the questions quickly. They're not making up numbers to make you happy, and they're also, if they're answering it more quickly, that means the survey is going faster, which means you can get more survey samples answered within your budget, which means you have better sample sizes and therefore better statistical properties with your work, and so on and so on. It just has benefit after benefit. So the method that we use it's a survey approach that is a relative scaling approach. And that relative scaling approach we find can really work for all kinds of stakeholders. And we've done lots of publications on this in our other resource areas. And it can measure a wide variety of effects. And the way that this works is instead of asking people, what's your willingness to pay, or, what you ask instead, is something somewhat more valuable, much more valuable, not those terms, I'm simplifying the terms, but there are special language that you use for different valuations, or somewhat less valuable, or there are negative words as well. And you ask them compared to something that they they can relate to, and that's a known dollar value to you. It doesn't necessarily have to be a known value to that dollar value to them, but it has to be something they recognize and they would have assigned some dollar effect to in their brains. And if you ask if something is somewhat more valuable, much more valuable, or that sort of thing, but enhanced language on that, then this known value, then you can use, it turns out that the academic literature and the primary research that we've done shows a one-to-one relationship between specific words, labeled words, and a multiplier. They may not know what that multiplier is, but if you do internal research and you ask, and you either from in-sample or academic work, it is shocking how consistent those kind of modifiers, those labels are in coming up with a translated multiplier. So that means, let's say the average was much more valuable, and let's say the multiplier value for that is 1.5. I'm just making that number up right now. Then you can, and let's say that the thing you asked about was, then a piece of candy. I don't know, a dollar piece of candy, but you didn't say the dollar. Then you can multiply that 1.5 times the dollar, and that is your dollar value for this effect. It's pretty amazing. It answers things really quickly. They are nonlinear again, and we've developed these factors over time, and we've compared them with literature values as well, and past research that we've done, and that can get us to monetized questions. And further, in these surveys, we can ask about a whole host of effects. We can get together lists based on, say, our own research or our own thinking and our own brainstorming and our work from the literature, but also maybe you do some focus groups up front to get a longer list. And then, by simply asking whether something is a positive, a negative effect, or a zero effect, you narrow it down to those things that either have positive or negative effects, because the zero effect is zero. And then you ask these special questions about those things that are positive and negative, get the word values and translate those to multipliers and figure out what your dollar effect is. You get it and we've asked it for, I think the maximum number we've asked is about 15 different effects. And in one survey, and that gets us a lot more than a case study of how much the trucks are valued at driving down the street and being more noisy in a neighborhood. So it's a far more powerful, far more robust effect, and you can get sample sizes that let you make real statistical inferences about how valuable these effects are and what your error bands are and that sort of thing. Really, really broke through in a lot of the resource work that that we do in trash and other things, and it's a real breakthrough. We've used this for a number of studies, and I'll show you some examples of an example coming up. But this is an important change. On a higher level, I want to also remind you about social effect. Valuing things is very important, but if the valuation you're using is really squishy, that is probably not going to convince engineer types or whatever, or skeptics, and it's going to raise a little bit of a question. If it's really kind of squishy, they might say, oh, you picked that because you're trying to make a case and you're leaving out a bunch of other stuff or whatever. So do think at a higher level. This is not related to the methodology I just talked about, but rather it's at a higher level, stepping back. When we're looking at TBL on the social side, if the valuation we're doing is really squishy, that may or may not be more valuable than not doing it. Or you might want to discount it or put a star next to it or something and say, we're obviously confident this is greater than zero, but the thing may range. Well, then large ranges can also undermine your result, because they'll just say, you have no idea what you're talking about. It's 2 to 200, and truly that does not help. It might be better to say 2 as the conservative estimate, and maybe in a footnote somewhere or something say the methods, other methods imply it might be much higher or something, but try to make your case if you're making a decision case, try to make your case in a conservative way that's going to leave you less liable to pot shots and so on. And that might be the case. For instance, there are, as I mentioned, there are multiple values for metric tons of carbon equivalent. 40, or metric tons of carbon dioxide equivalent, 40 versus 200. That's a pretty big range. If it turns out 40 will get you to your decision of a plus, then perhaps putting 40 in and then asterisking the higher value down below would be a way to make it say, you know, conservative, the most conservative values in literature or something like that, rather than the most whatever. Simpler can also be beneficial and maybe enough to get you what you need to make a decision. It again you'll want those higher numbers for your own internal assessment of this is kind of the impact that people are potentially experiencing because of all the health and safety and illness and avoided statistical deaths and all that sort of stuff as well. But if you're trying to make a case before a council that has some skeptics on it, you know, the people who are more believers in sustainability stuff will already potentially be with you. The skeptics, you don't want to be liable to potshots and make a case that then the whole thing crumbles because of one aggressive number that you put in that turns out not to have been necessary. So consider the threshold or break-even analysis, and you know, how much value do you actually need to make that difference? You know, what set of these is the most? What set of the social things is the most reliable estimate? And make sure those are up front, and those are the basics, and those are used to get past the threshold. And the others may be included as well, but in sort of the more aggressive case or something like that. So calculate that minimum that you need to translate to positive, or if you don't know some of the numbers, say if the value of this list of social things is at least this dollars per ton, or at least X tons are reduced, or something like that, some very credible number, then it's positive, and this decision should go forward. It can help bolster your case rather than leading you down the path of ending up with fighting individual numbers or values that then lead everybody to get skeptical about the whole analysis, or making a case when you can't find values. So anyway. Also, please, when you present this stuff, I mean, I have had to go through reports in so many different chapters to find all the numbers that they estimated. They've got the results for one thing in this chapter and another thing in this chapter, and honestly, the executive summary did not include all the results. Seriously, make it easy for us to figure out what the decision or the advice or the whatever is. What does the information, what does the literature tell us? What does your calculation tell us? And it can be subtotals. You can say from this page, from this page, from this page, and then summed up, or with just this and this, you know, maybe just the economic and environmental is worth showing, and maybe that's the case, and you show the social as well, or maybe it takes all three, but show subtotals and totals. Also, you know, might be dollars, but consider benefit cost ratio. Even better, and for true economic analysis, you'd be wanting to look at the stream of benefits and the stream of costs. So the costs may be quite short term, but the benefits may go 20 years into the future. You want a discounted stream of benefits over the relevant lifetimes. So each of those benefits you have will have different lifetimes associated with them. The costs may be a construction cost, and maybe that's 4 years, or the benefits may be 20 years long, or things like that. Pulling that together using appropriate discount rates, and for cities, they tend to be sort of social discount rates, which are kind of much lower than bank discount rates or business discount rates. So those sorts of things tend to allow evaluations of things that last 20 years to have bigger value than businesses who, you know, 3 years from now, they can't even think about it, but and they discount appropriately. Anyway, that lets you understand the fuller, less biased benefit costs results and the benefit cost ratio in a real lifetime encompassing decision, not, you know, compare current year to current year. That's not really the picture. So really important. That includes the social benefits as well. A couple of project examples just to give you an idea of how this gets implemented and whether to what degree it has effects as well. So we're going to talk about two projects. One was a large-scale comp plan that we did for a county, and that includes a whole portfolio of residential, commercial, C&D options, and so on. And the second program is just in a downtown area. They changed the way that recycling was going to be collected from businesses. So it was going to move from dumpsters to bags. And both of them, they start out negative because they're, in both cases, you're having to go for, you know, more costs, and that includes, you know, increasing cost for delivering the residential and commercial recycling programs compared to what it is if it's all just treated as trash, and so on and so forth. The benefit cost ratio would have been was negative, and the ROI, payback, all that stuff, all more costs than benefits when you looked at the normal direct case. Basic economics, when we looked at it, it was, let's see if I can get this impediment out of my way here. Okay, there we go. So it was minus $1,294 per ton for that change for moving recycling collection from dumpsters to bags in the commercial downtown area. And it was minus $58 a ton for the incremental program costs when you're talking about the county comp plan changes. And when you have net of tipping fee changes and other things, it that added another negative here and a positive there, but it didn't make much difference. When we added some economic impacts like output and tax multipliers and a variety of other things, the road impact and so on and so forth, we still ended up with a negative impact of $34 a ton on this side and $1,255 a ton on the other project. Looking at the environmental portion, we did the calculation, and in this case, the emissions effects were about $271, and we have that Cape Town number that's pretty weak, but anyway. And what we found then is that the subtotal for environmental here was $289, and looking at how that compares with the with what we had for the negative on the previous page, we find that if we add that to the previous numbers, we get a positive $255 per ton for that program change if we use the economic and environmental for the comp plan. We haven't talked about social, but those two get us to the number. And on the program change for the commercial sector, we still find a negative $922 a ton. Social's going to have to do a lot. On this side, for program B, we used some the special surveys that we talked about, and using very local program specific information, and doing surveys on those people affected. On this side, we didn't even need to do any calculations, because in fact we had it had already gone positive just from the social, the economic and environmental. But when you add social in, you get an even more positive number. So yay for that. What we found was that the businesses and the residents in that downtown area had a whole host of effects from this new program that made the alleys less cluttered, made less crime happen in these alleys, made it freed up parking zones for businesses throughout downtown, made the alleys more useful for things like, you could have table and chairs out there and relaxing areas and lungs of the city benefits and those sorts of things. That was extremely valuable to the residents in the lofts downtown, to the businesses and so on, to the tune of thousands of dollars. And we talked not only to residents, but also talked to police for enforcement and others. And it was really, really valuable, and it turned that negative number into something positive. Now, we wouldn't even have to take this whole value to turn that positive. And what we might say is, the estimates were this, but even if only a quarter of that is you're willing to accept a quarter of that value, it still turns the decision positive. This is the kind of thing you can do with these kinds of numbers, and it turned the per ton value positive. So there you go. And we did the break-even analysis. How much of the social was needed for the comp plan? Zero. You could have $255 less of the environmental and economic things, and you would still be positive. And in this case, we needed $922 of the social effect, but we had much more than that. And that worked out to, would you accept even a quarter of the value of that we estimated? So there you go. You can also go about, trying to make these cute or whatever, and here's the negative side, and for the this was the county program, the left-hand side one. We've got negative $50 a ton, and gee, if we put in the benefit side of it, the different, it's 0.9 to 0.95 to 1, so almost 1 to 1 all by the economics. Add the environmental avoided emissions effects, and we turn something that's about 1 to 1 into something that's 8 to 1. And you don't even need the social effects. The social effects would be gravy on top of this. You only need about $2 of the social cost of carbon effects as well. Those are different things. And while those things are important, you may find you're using, maybe you're using this to figure out what should we be using for our sources and what should be the rankings of different programs in our comp plan. Well, if you attach the environmental effect and the social effect on some of these, you may find that your ranking of different programs for how to meet our diversion goal would change because of this TVL analysis instead of just the simple cost analysis or the cost plus generator cost analysis. What are our conclusions? Well, there's, even estimating this list of effects is really not that hard. We do it pretty routinely for our clients, and it gets you a reasonable number of economic, environmental, and social effects for recycling, diversion, long-term waste management types of programs. The TVL steps are, TVL is important and the social is rarely quantified, but communities really should try to work through all parts of TVL as far as they can. Monetize what's possible easily, maybe do a hybrid scoring for the other part, and estimate your totals, the cost ratio, and so on, and check your results with what you can do easily. If it's clearly greater than 1, if the decision is clearly a plus, if you're clearly, the decision is more benefits than costs, then you might be done. And that might be all that's needed. If it's not, and again, for a decision, for understanding the better benefits, the fuller benefits to people, then you would want to go on. But this is maybe as far as you need to go before council. And maybe you do a list for the rest or the scoring for the rest. If it's not clearly greater than 1, but you have left some big ticket benefits, positive or negative, but especially, on your list, you may want to conduct some additional research. And it's not just to make your case, but to avoid a biased decision. If in that nine cell matrix, there are things that are high impact that you have not measured yet, you may want to do that and then list the other items or conduct a threshold analysis. If you think this big thing is bigger than X, then our decision is positive. So TBL is feasible and it's improving and it's appropriate, especially for cities. In summary, there are 3 elements to look at beyond your simple benefit cost. Cities should be examining these perspectives because and especially including the rarely quantified social, because it is part of your responsibility. And all of this information does not make the decision. You're not the council. As a consultant, I've learned very well, I am not the council. I can merely inform the council in the decisions that they make about a program or the staff or the whatever. But it's an aid in decision making. You can inform people in a way that's not biased, and you can give them the information and they make their decision. But at least it's the best information you can provide. A break-even analysis may really help with skeptics because while they may not be willing to take the whole enchilada, they might say, that is kind of a lot of stuff. It probably is worth 2, 5, 10, whatever dollars a ton when you show me what some of these others are worth. You definitely need to go beyond hand waving. This has been, happening for a long time. TBL is not, yesterday's news. It's several years ago's news, and it really does bear a serious look at. And let's see, the capabilities do exist, and we can really improve what we're doing and provide a much better picture, much more informed decisions. So thank you for your attention, and I'd love to entertain questions.
Okay, thank you, Lisa, for that great presentation. A lot of valuable information for sure. So we're now going to field some questions for Lisa. If you have a question or a comment, please use the feature on your control panel. So have one here. We have a question here. What is an effective strategy to increase survey participation?
Oh, that's a really good question, and getting more better and better as the days go on. It's we used to be able to expect, for program participants, we could expect maybe 40–50% participation in a survey as a follow-on, but now you need incentives for everybody pretty much nowadays. And there are a couple of different ways of doing it. For a while, we found that people would do anything for a $5 gift certificate to Starbucks. That's becoming less true, especially and so now we're doing two parts in a lot of cases where we offer some dollars per complete and also a chance to be in a lottery for a bigger number. So that seems to help some. Another is an offer to for that or donating to charity, and they can pick from one or two charities and that sort of thing. That's mainly how we have to do it. And I really hate to say it, but more and more you have to kind of pay for survey responses. And there, so that's mostly it.
Yeah, I just want to add to that. The Recycling Market Center works closely with our organization in our building called the Center for Survey Research. And they basically transitioned from the typical phone call polling, gone to online web-based polling, which has resulted in a lot better participation, and also the incentives for small gift certificates and so forth. So all those tools have worked in getting higher participation rates in our surveys that we do.
We've had to use web surveys for about the last 5 years, pretty much full scale, and they have to be visible. The one thing that you have to remember about the web surveys is they have to be visible on a phone, because more than half of people, or 40% or more than half, I can't remember the number, do it on a mobile device like that, and they don't do it at their computer. So it's really, we do surveys every day, and so that is one of our main jobs. And so it's really important that you look at that as well.
Yeah. Have you or anyone done an analysis after a TBL decision has been made, an action implemented to see if the accuracy of your method? A little bit grammar there, but
I understand. Tonnage numbers, yes. I have not done a second, I've not gotten the funds to do a second survey approach later to see if their valuations of effects that they actually realized bore out compared to the ones that they thought they would realize. And while we would love to do that, that has not been a project I've had the privilege to do.
Okay. I'm going a little off topic here, but the Recycling Market Center has done a statewide recycling economic impact study, and other organizations have done them too, like NERC have done one for the Northeast region. I think Texas just did one, and some other states are doing them. Would this work in a larger scale study or project?
The recycling economic studies that I've seen have all been about jobs and economic multipliers.
Right.
And those are most of the ones I've seen where they've made a statewide level or regional levels, or at least the ones that NRC commissioned a number of years ago. I think you guys commissioned, and some regions used the input output models I talked about, bought that local whatever data, and came out with the tailored multipliers for that area. Mm-hmm. That's what was done. And so yes, that can be done at any area you want to buy that data for. So it's pretty straightforward. Put in the numbers for recycling, see what comes out pre-post, and come up with those multipliers. Right. Do the same for organics, do the same for whatever. It's really just a modeling exercise. But it does require some potentially controversial assumptions, as we saw in that earlier round, about how much of XYZ you consider recycling and blah, 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 blah. So it does involve some choices that should be well vetted.
Right. If web-based, how do you determine statistically representative of the community?
Great question. We always include questions that relate directly to the demographics that they include in census, so that we can then compare the results with the census percentages as they should go. And then if they don't come out if you've got way too many people who are 65 and older who filled out your survey, gee, that never happens. If that's the case, then we weight those down and we weight up the other age groups to the percentages that are needed. Or if it's that's the sort of thing we do. So we post weight.
I should mention that surveys we do also include phone surveys in combination with online. And now that mostly everybody has a cell phone, they're getting the cell numbers versus the the white pages. So it's just kind of, you roll with the changes.
Yeah, when you look at Dillman and other best survey methods approaches, there are a number of steps that you should use for best approaches. I'm giving a shorthand here. But yes, there's pre-notifications and and that sort of stuff, and then samples of follow-up surveys for a sample of the non-respondents and a number of other things like that. So for getting at reducing bias from surveys and having that the respondents to the non-response survey stand in for the people who didn't respond and weight them differently and so on. Yeah, we use all those methods, and yes, sometimes that does involve multimodal as well. That is in the best practices manuals.
Good. Okay, I think that's it for the questions. So we're gonna wrap it up. Great questions, everybody. So again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thanks again for joining us, and we hope you'll join us for next month's webinar. And please visit the NRC and RMC websites for schedule updates. And thanks again, Lisa, for taking the time out to make this presentation.
And please email me if you have more questions that come up later. Thank you.
Okay, thank you. Have a great day, everybody.
Thanks.